Hi, this is Francis from A+ Tutoring. In this session, I'm going to show you how to evaluate this integral that's in the Stewart textbook, chapter 7.2, number 47. Okay, so I have integral of 1 minus tangent square x over secant square x dx. Now, what do I want to do in this integral? I can actually do this. 1 minus tangent square x over 1 plus tangent square x dx, right? Because I know secant square x is basically 1 plus tangent square x. This is one of the identities, right? But however, if you look at this, 1 plus tangent square x, this cannot be factorized and cannot be simplified with the one on top. So I would say no to these identities. What if I change the top one, tangent square x? Well, I can do that, right? So if I change it to secant square x minus 1, right? I can have something like this, and then 1 minus minus 1 becomes a 2. So this is becoming 2 secant square x, right, integral of that, and then minus a secant square x over secant square x. So I separate the fraction so that you can see. So on top is supposed to be 2 minus secant square x. And I separate the fraction so that I know I have 1 here. So this is basically 2 integral of cosine square x dx minus dx, 1 dx, right? So that's 1. And this one is becoming this one, right? 1 over secant square x is cos square x. And what is cos square x? Cos square x is basically 1 plus cos 2u over 2. Okay, so basically if you following this, you can still transform this into 1 plus cos, so 1 plus cos 2x over 2 dx, right? Minus integral of dx. Now, if you look at this, this is becoming easier. You separate this integral into 2 parts again, and then use a simple substitution for the 2x so that you can have the integral of cos u. Now, this is okay, right? I can show you another way that is easier. Okay, so if you look at this tangent square and secant square, I want to separate this fraction right away. So this is going to be 1 over secant square x minus tangent square x over secant square x dx. And then I want to change everything into sine and cos. Okay, so this becomes cos square x minus, so this is sine over cos divided by 1 over cos. So all you have left is sine square x and then dx. Now, if you look at this, this is cos square minus sine square. What is that, right? So if you think of these identities, this is plus in between them. But there is another one. This one is we call double angle formula. Cos square minus sine square. This is cos of 2u. Okay, this is cos of 2u. So this is becoming integral of cos 2x dx, right? Now, if you look at this here, this is actually becoming to the same thing, right? Here in this part is going to be 2 over 2, right? That will be 1. So integral of dx plus integral of cosine of 2x dx minus integral of dx. And the first term and the last term cancel, and it becomes the same integral. Okay, but however, this is more step to do, and this one is actually easier, but you have to think of all the identities. Okay, both way works, and it ends up to be the same result. So let's evaluate this integral here. Integral of cosine 2x dx. Simple substitution, u equals to 2x, du equals to 2 dx. So du over 2 is equals to dx. So this is becoming integral of cosine of u du over 2. And cosine of u, the integral, is basically sine, right? Sine of u. So I have my answer to be sine of u over 2 plus c. And what is u again? I have to put it back as x, right? 2x. So this is going to be sine of 2x over 2 plus c. And this is basically my final answer for this question. So you see the process of using trigonometric identities. You can actually have several different ways to do this. There's no correct way. It's just which way you can think of it faster and easier to do. Okay, you can still use this one. It's just a little bit longer, but I would encourage you to try to remember all your trigonometric identities so that it will be easier for you to evaluate integrals. So for more information about integrals on trigonometric functions, please visit my website goforA+.com.